Welcome to a slow, beginner-friendly lesson on calling an API from Python, made for absolute beginners. Real code begins. Today is a milestone. For the first time in this course, your Python leaves your own machine. You will write a real GET request, send it to a real server across the internet, and read the answer that comes back. The library that makes this almost easy is called Requests, the most popular third-party library in the Python world. Last lesson you learned the rules of HTTP, methods, status codes, headers, URLs. Today you see all of them appear live and running code. By the end of this lesson you will have fetched real data from a real API and printed it with your own Python. A milestone lesson. Recap where you are. You can store values, build collections, write loops, call functions. You understand what an API is.
You know the rules of HTTP, GET, status codes, headers, the parts of a URL.
The only missing piece is a Python library that speaks HTTP for you. That library is called Requests. It is not part of standard Python, it is third-party, so you need to install it. But here is the good news: with UV, the tool you learned early in this course, you can run a script with requests available, no project setup needed. One command. Let us start there. Rules become code. Today, for the first time, your Python leaves your machine. One line sends a real request across the internet to a real server, and waits for a real answer. Your code leaves the machine. Here is the beautiful part. You do not need to create a project, set up a virtual environment, or write a configuration file. UV, the tool you learned early in this course, has a flag called --. With. When you run UV run --, with requests python script.py, UV notices you asked for requests, fetches it if it is not already available, and runs your script with it imported. One command. Behind the scenes UV handles the isolation, the caching, the version resolution. You just write your script and run it. This is the modern Python workflow, and it is perfect for learning. No setup, one command. Save this tiny script as fetch.py. It imports requests and prints the version number. Now run it with UV run --, with requests python fetch.py. The first time you run this, UV downloads requests and its dependencies. It may take a few seconds. The second time, it is instant, because UV caches everything. You will see the version number printed. That confirms requests is available and your script can use it. From here on, every API call is just more code in the same script, run the same way. UV handles the install. Every API script you write starts the same way, import requests. That single line makes the requests library available in your script. The name requests is now a module you can call functions on, requests.get, requests.post, and so on. You can also check the version with request under version, which is useful when something behaves oddly and you want to confirm which version you are running. But day to day, you just type import requests at the top and move on. That line is the door. Everything else in this lesson walks through it. The door to every API script. Here is the shape of every first GET. 1. Import requests at the top of your script. 2. Call requests.get with a URL that sends the request across the internet. 3. Check the status code on the response object. Did it work? 4. Read the data, either as raw text or as a parsed Python dictionary. 4 steps. You will type them so often they become muscle memory. The power is not in any single step, it is in how little code each step takes. 2 lines send a real request and hold the answer. Let us walk through each step in real code. 4 steps, every time, the answer comes back wrapped in a single Python object. Status code, text, headers, data, all tucked inside one response, ready for you to inspect. The response arrives. Here is the line that does the real work. You import requests, you set a URL, here, the GitHub API for the CPython repository, and you call requests.get with that URL. That single call does 4 things behind the scenes. It opens a connection to the server, sends a GET request, waits for the answer, and packs the whole response into a Python object. When you print the response, you see response in brackets, then the status code, 200. That single line is the network call. Everything else is just reading what came back. The line that does the work. The first thing to check on a response is the status code. Response.status code gives you the 3-digit number you learned about last lesson. 200 means success, the server understood your request and is sending data back. 404 means not found, you asked for something that does not exist. 500 means the server had an error on its side. Always check the status code before you trust the data. A simple if statement comparing to 200 is enough for most beginner scripts. If the status is not what you expected, Print it and investigate before going further. Always check first. Response.txt gives you the raw body of the response as a Python string. If you print its type, you see class str, it is just text. Slicing the first 80 characters shows what the server actually sent, a chunk of JSON, but as one long string, with quotes inside quotes. This is useful for debugging. You can see exactly what came back, but it is not yet Python data. You cannot do square bracket lookup on a string and expect a field by name. To turn this text into real Python dictionaries and lists, you need one more method, which is the next step. Raw, but not yet data. Raw text becomes a Python dictionary with one method call. JSON in, dict out. The collections you already know are the key to reading API data. Text becomes structure. Here is where the magic happens. Response.json takes the raw JSON text and parses it into real Python data. The type is now dict, a dictionary, exactly like the ones you learned in the collections lessons. You can look up fields by name with square brackets. Data square brackets name gives Python. Data square brackets stargazers_count gives 64,000. The API just became a Python dictionary. This is why we spent so many lessons on dicts and lists, because real API data arrives as exactly those types. You already know how to read it. Magic in one method call. Response.headers gives you the headers the server sent back. It behaves like a dictionary. You look up values by header name with square brackets. Content type tells you the format of the body, here, application JSON with UTF-8 encoding. Date tells you when the response was sent. There are usually many more, cache rules, server identity, rate limits, but you do not need most of them as a beginner. The two worth knowing are content type, to confirm you got JSON back, and sometimes rate limit headers, which tell you how many more calls you can make before the server asks you to slow down. Metadata from the server. Once you have the data as a dictionary, you pick the fields you care about and print them. Full name gives Python/Python. Stargazers_count gives 64,000. OpenIssues_count gives 1800. Language gives Python. Notice the last line uses .get with a default value. If homepage is missing, it returns the string none instead of raising an error. That is a safe pattern you learned in the collections lessons, and it is exactly the right tool here. Real API data sometimes omits fields, so .get is your friend. Pick what you need. Notice how the HTTP rules from last lesson map directly onto the requests library. The method, get, is right there in the function name, requests.get. The status code appears as response.statuscode. The headers appear as response.headers. The body appears as response.text for raw text, or response.json for parsed Python data. Every part of HTTP you learned has a matching attribute on the response object. The library just wraps the protocol in friendly Python. Once you see the mapping, you never forget it. HTTP, made visible. Hold this mapping firmly, because it is the bridge between concept and code.
The method, get, post, and friends, becomes the function name, requests.get, requests.post.
The status code becomes response.statuscode. The headers become response.headers, which behaves like a dictionary. The body becomes either response.text for raw text, or response.json for parsed data. Every rule from the HTTP lesson has a home in the requests library. You are not learning something new, you are seeing the same ideas wearing Python clothes. The mapping holds. Here is a complete first script, end to end. You import requests. You set the URL to the GitHub API. You call requests.get and store the response. You check the status code. If it is not 200, you print a failure message and stop. Otherwise you parse the JSON and print 3 fields, the full name, the star count, and the open issues count. Run it with uv run -- with requests python fetch _repo.py. That is a real API client in 15 lines of Python. Everything else you learn about APIs is just variations on this pattern. 15 lines, real client. A few patterns repeat in almost every API script you write. First, always check the status code before trusting the data. A 500 response has a body, but it is not the data you wanted. Second, call .json to turn the text into Python data. Third, access fields with square brackets when you are sure they exist, and with .get when you want a default. Fourth, print the values you care about, or store them in variables for later use. These 4 patterns cover most beginner API work. Master them, and you can fetch data from almost any public API in the world. The shape that repeats. Here is a short practice to make it stick. Fetch a different repository from the GitHub API, the requests library itself, at psf/requests. First, print the status code to confirm the call worked. Then, if it is 200, print the full name of the repo, the number of open issues, and the description field. Try it before reading the next lesson. The goal is to feel the shape in your fingers, import, get, check status, parse, print. Once that feels natural, you are ready for the next lesson on navigating the data that comes back. Try it yourself. Quick self-check. Can you run a script that imports requests using uv-with, without setting up a project? Can you call requests.get with a URL and store the response? Can you check the status code before you trust the data? Can you call response.json and get back a Python dictionary you can index with square brackets? If any of these feels shaky, rewatch the matching code example and try it yourself. The shape is small, 4 lines of real work, and it is worth holding firmly. Say each out loud. You can now fetch real data from the internet in 4 lines of Python. Run your script with uv run ---- with requests python script.py, no project, no virtual environment, no install step. Import requests. Call requests.get with a URL. Check the status code to confirm the call worked. Call response.json to turn the answer into a Python dictionary. That is the whole shape. Every API script you write for the rest of your career starts with these same 4 moves. The next lesson goes deeper into the data that comes back. 4 lines, real power. Now that you can fetch data, the next lesson teaches you how to read it well. Real API responses are often nested, a dictionary inside a dictionary, lists of items inside a larger object. You will learn to reach deep into that structure, pull out exactly the fields you want, loop over arrays of results, and print clean formatted output. It is the collection's lessons from phase 0.5, applied to real data coming back from real servers. The bridge between fetching and using is what we cross next. Fetching becomes reading. Thanks for your first real API call. Next we learn to navigate the data that comes back. Real code begins.